Welcome back everyone. Today we are going to solve NCERT problem number 1.2 from some basic concepts of chemistry. The problem is a compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molar mass is 98.96 grams. What are its empirical and molecular formula? So we have already know that what is empirical formula. Empirical formula is the simple representation of the molecular formula, in which the molecular formula is represented in the simplest whole number ratios. Okay, for example, if there are two elements, that is carbon and hydrogen, for suppose we are talking about ethene, C2H4. Okay, so if we take the ratios, we can say that this is the molecular formula, but we have to calculate the empirical formula. Its empirical formula will be CH2. It is the simplest representation of molecular formula in which they are present in the simplest whole number ratios. So this is called empirical formula. So we are going to calculate it. Okay, now in this particular question, we have been given the percentage of hydrogen. So we are going to write down percentage of hydrogen. All the hydrogen's atoms, the percentage has been given, which is 4.07%. We also have been given percentage of carbon atoms, so that is 24.27%, and percentage of chlorine is also given, that is 71.65%. Now, which means that this particular organic compound, it may be organic compound because carbon, hydrogen are present over here along with chlorine. So this compound has hydrogen, carbon and chlorine, three elements. Okay, so once more thing which is given over here, this is the molar mass of compound, which is 98.96 grams. So as we know that we have to convert these percentages, because these are the weight percentages, mass percentages. Okay, so these are mass percentages. So we have to convert them into mass. Okay, so let's convert. That is mass of hydrogen atoms has been given, which is, it is given 4.07 according to mass percentage definition, that 4.07 grams of hydrogen is present in 100 grams of compound. Okay, so 4.07 gram is given. Okay, then mass of carbon atoms, they may be atoms or they may be one atom, has been given, which is 24.27 gram. Okay, and the mass of chlorine atoms, it may be single atom or it may be different, multiple atoms. So it is 71.65 grams. And suppose, okay, suppose that total mass or weight, okay, or weight of compound has been given, which is, suppose this is 100 gram, because we are taking these values from percentage. Okay, so now what we are going to do, we are going to convert them into the number of moles. Okay, so we are converting into them into the number of moles. So moles of hydrogen will be equal to, what will be there? The given mass divided by molar mass. Given mass divided by molar mass. And if we talk about hydrogen, its given mass is 4.07 gram. Okay, and its molar mass is approximately 1. We are taking 1. It can be written as 1.008, and this is approximately 1 according to its significant number. So it becomes 4.07 because it is a moles, so there will be no unit. Next is moles of carbon. So that will be 24.27 gram, which is the given mass of carbon, and carbon's molar mass is 12.01. You can take it 12.0 also. Okay, so it becomes 2.021. Okay, next is moles of chlorine, right? So chlorine has been given 71 point, it is the heaviest in it, 71.65 grams, and chlorine's mass is 35.5 approximately. So we are taking like that, and its answer will be 2.021. So we got the number of moles for each and every element which is present over here. Okay, now what we are going to do is we are going to convert these mole values into smallest whole number ratios. Okay, so what we are going to do in that, what we have to do, we have to divide all the moles by the smallest number. Okay, so to get the whole number, ratio, okay, what we have to do is we have to divide moles by smallest number of moles. Okay, okay, suppose I'm calculating from hydrogen. I can show it like this, that this ratio will be ratio for hydrogen, which is equal to the number of moles of hydrogen, which is 4.07, divided by smallest number is 2.021. Okay, which approximately comes out to be equal to 2. Okay, it is approximately 2, so we can take it like this. Fine, this is the ratio of hydrogen. Ratio of carbon is, its mole is C 2.021, and it is divided by smallest number, which is 2.021 once again, and it is 1. Fine, now we are calculating ratio for chlorine. Ratio of chlorine, right, for number of moles 2.021, and the smallest number once again 2.021, and once again it becomes 2. So what is the ratio of hydrogen, carbon and chlorine? It comes out to be 2, 1 and 1. So by this ratio, okay, we can calculate the empirical formula. Okay, what we have to do is we have to multiply. Okay, we have to multiply the symbol of element with its ratio. Okay, so its formula becomes H2CCl. So its empirical formula will be H2CCl. It can be rearranged. Okay, H2 can come over here and carbon can go there, because it may be a I have told you earlier also, this may be an organic compound, so CH2Cl. But now this is the empirical formula. Okay, what we have to do now to convert it into the molecular formula, what we have to do, that we have to calculate its mass. Okay, so mass of empirical formula is, okay, so what we have to do is, once again I have told you earlier also how to calculate the mass. So we have to write down the masses of all the elements separately, okay, multiplied by their number of atoms. So carbon has 12 gram approximately, I have told you. Hydrogen has 1 gram, but there are two hydrogens, so multiplied with 2. And chlorine is 35.5 gram. And when we calculate this, it becomes 12 gram plus 2 gram, which is 14 gram, plus 35.5 gram. Okay, and we can calculate in the grams what becomes. It becomes 49.48 grams. Okay, this is the mass of empirical formula. Okay, but as you know, we are going to the very top of our question. The actual mass of compound has been given, which is molar mass of the compound is 98.96, which does not resembles to the mass of empirical formula. It means our molecular formula is little bit different. So how can we calculate it? We have to calculate the n factor. Okay, n factor is a factor which can be multiplied with the formula of empirical formula. Okay, multiplied with the compound's empirical formula. So we have to calculate the n factor. So n factor will be equal to, n is equal to, okay, what we have to do is molar mass, because molar mass of the compound has been given, divided by empirical formula mass. Okay, empirical formula mass, I am writing it EF, so you can be able to get it, that EF is empirical formula. Okay, molar mass has been given, which is 98.96 grams. Okay, and empirical formula mass we have already calculated, which is 49.48 grams, right? Okay, the n factor comes out to be equal to 2. Okay, so n factor is 2, and I have told you that this n factor should be multiplied with empirical formula to get the molecular formula. So we are getting molecular formula of compound is equal to n multiplied by empirical formula. So n is 2 and empirical formula is CH2Cl. So what happens with that, every atom becomes double, because n is 2, so every atom becomes double. So that means the carbon becomes double. Carbon was 1, now it becomes double, means C2. Hydrogen also becomes double. It was 2, now it becomes 4. And chlorine also doubles, that is, chlorine was 1, and then after multiplying it with 2, it becomes 2. So the molecular formula of the compound is C2H4Cl2. and empirical formula is CH2Cl. So these are the only two things which were asked from us, that is calculate the molecular formula of the compound and empirical formula of the compound. So this justifies our answer. So this is how you have to calculate these kind of questions which are given in your chemistry book. Thank you so much everyone.